All right, let's finish up this lesson. We can make the expressions a little bit more complicated by including some multiplication. And to do this in the simplification process, I want to review the distributive property with you. So the distributive property is when you have a number being multiplied to a sum or a difference. So we're putting that sum or difference in parentheses. Now, typically, if we were to follow the order of operations, we would want to do what is in the parentheses first and then multiply, just like we had been doing when we were evaluating expressions. But in this case, now that we know that x minus 8, what's in our parentheses, now that we know those are not like terms, we can't actually do the x minus 8. Another way to think of that is if you don't know what the x is, you can't actually do the subtraction. You can, however, do multiplication. Multiplication is one of those operations that you can do if you don't have, even if you don't know what the number is. You can represent the multiplication by putting the two things next to each other or doing the multiplication. And so the distributive property allows us to kind of override the parentheses here. So we would take the outside number 4, what we're multiplying by, or how many copies of the x minus 8 we have. We would multiply it by the first term, and we would get 4x. Now again, we don't really know what 4x is as a value. We're just writing it as 4 times x. If we have subtraction, we bring it down to subtraction. If it's addition, we would write addition. And then we know how to do 4 times 8. That is 32. So 4 times the quantity x minus 8 is 4x minus 32. Or in other words, 4 copies of x minus 8 is equivalent to 4x minus 32. And you could double check this if you wanted. If you wrote out x minus 8 4 times, if we had 4 copies of that, we would have 4 x's and then negative 32 if we would add up all those 8's, negative 8's. Oh, I wrote 4x minus 4, but I meant 8 right here. I meant 8. So for this next one, I want you to notice we have 3x and 9y in our parentheses, and again, we can't simplify 3x plus 9y. They're not the same variable, and so they're not like terms. And we can multiply. Now think of our exponent rules again. When we did, for example, 5x squared times 3x squared, or whatever, 3x to the second, fourth, fifth, doesn't matter. Remember how we were able to do the multiplying of the numbers? Those were called coefficients at the time, even though we didn't know that word yet. We can do the same thing here. So 5 times 3x is just 15x. And again, this is using the commutative property of multiplication. It doesn't matter if we do 3 times x and then multiply by 5, or we multiply 3 and 5, which is 15, and then multiply that answer, the 15 by the x. And then we are going to distribute our 5 to our 9y, and 5 times 9y is 45y. What this distributive property allows us to do then, it allows us to simplify expressions otherwise we wouldn't be able to because of having the parentheses there. So for example, in our first problem down here, we're multiplying 2 times the quantity x plus 1, we're adding 6x, and we're adding 15. Now you might say, oh, I have an x and I have an x over here and I want to combine them, but I can't actually combine them without completing the multiplication first because that is the order of operations. So we can't do the parentheses, but we can multiply. And that's what the distributive property allows us to do. It allows us to kind of circumvent those order of operations by writing something equivalent. I would multiply 2 times x to get 2x. I would multiply 2 times 1 to get 2. And I would bring down all of my other terms. And now I can identify my like terms as 2x and 6x, which is 8x, and 2 plus 15 is 17. And 8x plus 17 is the simplified expression. If we wanted to go ahead and pick a number for x, like, even 5 or something like that, you could evaluate this expression for 5 when x is 5, and evaluate this expression when x is 5, and you would get the same numeric value. And so that's why we're saying that these expressions are equivalent, and we're using the simplification process. In the next example, I want us to notice that we have 5, and then we have 4 times something. We have this piece here. One trap that students sometimes fall into is they want to add the 4 and the 5 first, and they want to bring this down as a 9. The reason why we can't do that is because, again, the order of operations. We would have to do all multiplication before we do any addition. And so we don't want to add the 4 and the 5 first. And in fact, remember, we only have 4 copies of 3k minus 10. We don't have 9 copies. And so that's another way to kind of think through this, making sure you're doing that multiplication first. So we're going to distribute. 4 times 3k is 12k. 4 times negative 10 is negative 40. Bring down your 5. This is a positive because we're doing a positive 4 times a positive 3k. This is negative because we have a negative 10. And then minus 6k. Now everybody's a little bit different here. If you want to go ahead and write this as addition so that you remember the signs of who's negative and who's positive, go for it. If you feel comfortable without that, that's okay too. This is a negative 40 and this is a negative 6k. That's just something I want to point out to everybody. And now we can add our like terms. Our k's, 12k and negative 6k is 6k, positive 6k. 5 plus negative 40 is negative 35. I'm going to write that as minus 35. It is the same thing mathematically as plus negative 35, but now we sort of try to avoid extra signs if we can. So I encourage you to add the opposite when you're thinking about performing an operation, but when you're just writing the expression, it's nice to leave it as 6k minus 35. But if you wrote it as 6k plus negative 35, that would be great. This last one I want to take a look at because we have our 10m, and this is what I'm going to tell you to add the opposite. I want you to notice that we have a negative sign in front of the 5. And so what we're doing is we're taking 10m and we're subtracting 5 copies of m plus 8. We're subtracting 5 copies of that. When we distribute, we want to make sure we distribute a negative 5. This is a negative because we're subtracting 5 copies. So we want, when we distribute, this would be a negative 5m, and this would be a, and I'm going to write that as a plus negative, just to really emphasize it, a negative 40. That is what subtracting 5 copies of m plus 8 would be. I would have minus 5 copies of m, and then I would also be subtracting 40. Okay, because that's subtracting 5 copies of 8 would be negative 40. And then finally, I can combine my like terms. 10m plus negative 5m or minus 5m is 5m. So what I'd like you to do is pause the video, try the example problems, and then I will explain them. The good news is that when we come back together in class, we are also going to be practicing this. This is not something that I expect you to totally master just after this video lesson. And so we will come together as a class and we'll be practicing. All right, well, I'm going to assume that you did your example problems, and now I'm going to explain them. In this expression, 12h minus 5 plus 9h, we want to identify the terms, like terms, constants, and coefficients. Remembering that terms are separated by addition signs. So I am going to go ahead and write everything as addition. So my terms are 12h, negative 5. It's very important. This is a negative term. And 9h. My like terms are my 12h and my 9h. My constant is negative 5. My coefficients are 12 and 9. Remember, coefficients are the numbers that modify a variable, the numbers that are being multiplied with the variable. For simplifying, question number 2, my like terms are my 7b, and this is a negative 6b. So I have 1b, or just b, and then 12 plus 8 is 20. So that is b plus 20. Over here, I really want to highlight this. Negative 3c plus negative 10 plus negative 14c plus 11. So I have a negative 3c and a negative 14, that is negative 17c. Negative 10 plus 11 is 1. So I have negative 17c plus 1. For question 4, we're going to start with distributing our 5. 5 times 2x is 10x. 5 times 4 is 20. And bring down our minus 8. Now sometimes you have to be careful here. This is a positive 20 and it's a minus 8, so it is okay to just go ahead and make that 12. We want to be careful here because if this were negative, that was a negative 20, we wouldn't bring that down as a minus 12. And we will do a problem like that in class when we're all together. For this last example, you would start by distributing your 3. 3 times 2w is 6w. 3 times negative 5, this is kind of what I'm talking about here, is minus 15. This was like when I was talking about that last problem. And then bring down our 9w and our 4. The w's are right next to each other, so I'm going to go ahead and add them. They're positive. 9w plus 6w is 15w. Now here's where I want you to be very, very careful. A lot of students will say, oh, 15 plus 4 is 19. Bring down my minus. But that is not what we have here. That is not how we want to think of this. We want to make sure we're thinking of the signs. This is a negative 15, and this is a positive 4. And this, again, this goes using the order of operations. Normally we add and subtract from left to right. So whatever we had, we would subtract 15 before we add 4. If we would add the 15 plus 4 and bring that down as a minus 19, that is actually violating the order of operations. Okay? But if we think of this as a plus negative 15 and plus 4, then everything is addition and our signs are correct and we don't have to worry about that because everything is addition. So negative 15 plus 4 is negative 11, and so we would bring that down as a minus 11 or as a negative 11. And we will practice this in class because this is definitely one of the key areas. Keeping out all track of our signs and making sure we're really attending to detail when we're working with the signs of our terms. So that is an introduction to simplifying expressions, and I look forward to practicing more soon.